For part B, I would encourage you to pause the video once again and give this a try on your own before jumping into the solution. So assuming you've had a go at it again, this time the function f of x is a product of two functions which hopefully you know how to differentiate sort of separately. This function can be differentiated by using the product rule. So essentially, the end goal of this question is to take the derivative and evaluate it when x is equal to pi on 4 or 45 degrees. But we use radians in methods, so please be careful. So if we have a function of x, which can be written as the product of two different functions, u of x and v of x, then the derivative of this function is given by what's called the product, which is given by the following. The way you work out the product rule is to take the derivative of the first function, u dash of x, multiply it by the second function without taking its derivative, plus the derivative of the second function multiplied by the first function without taking its derivative. That being said, let's make our identifications. So we'll let u of x equal sine of x and v of x equal e to the 2x. And let's just simply blindly apply this formula. So f dash of x is the derivative of u with respect to x. So if I differentiate sine of x with respect to x, I get cos x, and v of x is just e to the 2x. Remember, we are not taking the derivative with respect to x for the first term, plus, now the derivative of v of x, so v dash of x, is the derivative of e to the 2x with respect to x, which is just 2e to the 2x, and u of x is just sine x. We don't need to take its derivative because it's the second term now. So this is the derivative of f. This is using what's called the product rule. Now, all we have to do is to evaluate this derivative at x equals pi on 4. So all we have to do is to substitute x equals pi on 4 in this. So we have cos of pi on 4, e to the 2 pi on 4. I know this can be simplified, but I'm just going to leave it as is for now and then simplify it all at the end. So we got 2e to the 2 pi on 4 sine of pi on 4. Thinking back to our exact values, the cos of pi on 4 is the same as the cos of 45 degrees, which is simply root 2 on 2. You will be expected to know these off the top of your head for exam 1, where you don't have a CAS calculator or bound reference. I would highly encourage you to become familiar with exact values if you aren't already. And e to the 2 pi on 4 is simply e to the power of pi on 2. And then we add to that 2 e to the pi on 2, again, 2 pi on 4 just simplifies to pi on 2. And sine of pi on 4, once again, is the sine of 45 degrees, which is root 2 on 2. So essentially what we're left with is root 2 on 2 e to the pi on 2 plus the 2's here cancel out. We've got 2 times e to the pi on 2, and then we're dividing it by 2 from the root 2 on 2. So these two cancel out, and all we are left with is e to the pi on 2. So we've got root 2 e to the pi on 2. Now let's tidy this up a little bit. Let's pick out the common factors and make our answer look a little bit nicer. So what we have is we have a common factor of root 2 e to the pi on 2. So let's pull that out. Root 2 e to the pi on 2, a half plus 1. So essentially what this becomes is root 2 e to the pi on 2. A half plus 1 is 3 on 2. So we can write this as multiplied by 3 on 2, which means our final answer is simply 3 root 2 e to the pi on 2 all over 2. And this is how you would obtain 2 marks for part B of question 1. So hopefully approaching these problems makes a little bit of sense, at least some sense. If you are unfamiliar with the notions of product and quotient rule, I would highly encourage you to become familiar with these before the exam, because more often than not, actually extremely often, the first question on a VCAR tech-free exam tends to be based on the product and quotient rule. So hopefully this video has given you some idea on the kind of questions that you may be able to expect in the initial stages of a tech-free VCAR exam. And I'd encourage any feedback or suggestions that you may have regarding the presentation of these, so that I can improve my presentation for future videos. So thanks everyone for tuning in, and I look forward to seeing you either in Melbourne or on YouTube. All right, have a great day, everyone. See ya.